Okay, thank you. So I'm just going to flip a few slides, but then of course I want to get to the discussion part with you because your contribution is really valuable. So we have something called a large-scale system demonstrator in Sweden. A couple of cities with the climate contract saying that they're going to become climate neutral by 2030. We're competing, and there's like 5 government agencies supporting this in different ways. And this demonstrator in Lund is called Coaction, and our part is Coaction Energy. So basically, we believe that we've found a way to add the last piece to the puzzle. So we already had solar, wind, we had the batteries, but what we needed was a way to share these resources without being constrained by the gridlock of the old traditional electrical grid. Because the old electrical grid, actually the architecture is from the 1880s, 1890s, and it's really not suited for a lot of local production. So basically, it's the answer to this is really obvious once you find it, and it's really that we need to do an internetification of how we share energy. And if we do that, we're going to have a complete abundance. We're going to have, we believe, low fixed prices, starting with the housing sector, and we also create super resiliency. And we believe that this will be a paradigm shift, unlocking what we call the new energy society. So we call this the EnergyNet. And it's actually right around the corner and available right now. So the other part that is interesting with this is that it is so effective, and we don't need anything else than really commercial off-the-shelf components that are already at a hyperscale. So even if this is a starting point, the technology that we use is already super competitive when it comes to price performance. So it's much, much cheaper to build and operate than the traditional grid. And this is so effective, and the old grid has so many constraints and inefficiencies and bad policy on top of that, so that this is actually profitable to build and operate. So even when we build a parallel new existing system, that will remove all of these bottlenecks. So we don't need to upgrade the old grid with very lengthy processes and a huge amounts of money that everybody will have to pay for. So we really believe that the market will pay for it. And just to be overstating the obvious, that means that we are not depending on government handouts or other people's money. This is something that real estate people or traditional infrastructure funds or even banks can finance on a traditional simple cost analysis. But then, of course, there's also a lot of strategic advantages. What is the value of having an electrical grid that doesn't have to go down? What is the value of not investing trillions of dollars around the world in the old ineffective grid? So these are other externalities that add a lot of value. But even when we calculate on the simple money out, money in calculation, it is really, really profitable. So this is really just the quick background, and we call it solar wind storage instead of Toshiba solar wind battery, because we have different types of storage that we use, including green hydrogen. And then we call it EnergyNet, and the whole idea, and this is where we bring from the Swedish industrial experience, is that we create it as a system, because all of these components need to work together. And that is the software component part where we do the balancing. But the simplistic explanation is that we do an internetification of the energy system. And this sounds really good. The only two small details are that for the normal people, if there's such a thing, don't know how the internet works, and they don't know how the energy system works. But it sounds really good. But it's a really clever idea. And we've tried to take just a few of these advantages, and we can now build super resilient. So there doesn't need to be any single point of failure. We can now have an unlimited amount of local produced solar or wind without anybody having to say that. So even if California, for example, if PG&Es would say, no, you're not allowed to install that solar, or you're on a queue, you're waiting for long times, and it's going to be very expensive to put green local energy production in play. They can say, well, the technology now exists so that we can build another solution, which is, something that does not in any negative way affect the traditional grid. Actually, it's helping the traditional grid. So the more variable production, solar and wind, you put into the system behind EnergyNet actually helps the traditional grid. It decreases the complexity, it decreases the cost. And then, of course, we believe that it's so profitable, as we said, that it can be provided for by the market. And what is the big breakthrough here is that because of the war, Putin's war on Ukraine, the European Union did a huge deregulation. So from the 1st of January 2022, there's now, for the first time in 100 years, it is now legal in all of the 27 European countries in EU to build parallel electrical grids. We don't need the grid owner's permission. So if we want in our neighborhood or in our city or in our whatever part of the country, we are allowed to build parallel electrical grids, and we can implement EnergyNet, and we can prove the green and the financial and the technical stabilization of the traditional grid without needing a permission from the grid owner. So just one simple example, I come from a technology background. I was part of the team that when telephony systems were built, we didn't have the internet. And then when the internet became something that everybody wanted to use, there was a lot of constraints. There was a lot of gridlock on the phone system. So there was a big debate, and people said that they wouldn't allow more modems. That they talked about making, in Sweden, they talked about making modems illegal because the traditional grid couldn't handle the new traffic patterns. But then it was proven that we could build new parallel grids with fiber optics instead. And of course, now next year, less than 30 years after we started building parallel infrastructure, creating the modern broadband networks, the complete Swedish fixed line phone system is going to be dismantled and turned off. There will not be a single fixed phone line in all of Sweden less than 30 years after when we started. And it was by 85% in all of Europe, the fiber build out was paid for by the market, not by subsidies. And this, the thing we see on the map here is that, of course, in Europe, there's a lot of hybrid warfare from Russia. So this was a ship that pretended to have an accident, dragging their anchors and cutting off two really big fiber optical cables on the same go. And you can see that there's a long distance between those cables. Of course, that was a planned attack. But the thing was, these red dots are measurement points to see the internet traffic. And what happened was that even if these two really big infrastructures were destroyed by this anchor, not a single packet of data was lost, because it rerouted, because the internet architecture is built in such a way so that the information knows where it's heading and it can find its way independently. As long as there's a connection, the packets will find it. And this rerouting, as it's called, happened without any human needing to take an active action, because it's built into the architecture, and internet was built to be in such a way with not a central point of failure. So that's just a little bit about the background. And of course, we believe that this will pave the way so we can have low fixed costs for all the grid energy that we need. And if there's no questions, I'll just jump into a little bit about the new grid architecture and how we do this. Is there any questions so far, or should we jump in and talk a little bit about how we do this technically? Okay. So what we do basically is that we put a new box, the energy router. This is the green thing. We put that behind the meter. And then we connect to the traditional grid. We use the same way as we do electricity today. We have an AC connection, and we consume the electricity with AC inside the building. But this is done with something called power electronics. So basically, there's no traditional galvanic coupling between these two sides. We call them the B side and the A side. This is power electronics responding to digital signals, so that we are deciding with digital controls, not analog balance between in and out, where we are going, what kind of electricity and where we send it. And this means that we can now, on the D side that we call the left side, we can now put an unlimited amount of solar production, batteries, car chargers, without creating any technical problem for the grid. There's no problem with frequency, and there's a lot of other added values. I'm not going to take this too much, but this means also that we can build in real estate, we can use something called power over Ethernet. So we can use the data network to distribute DC power and communication to all of the critical infrastructure inside the building. And then this switch can be connected to two sides inside the system so that we create a really resilient distribution inside the building so that we can now prioritize what things should be on and off. But then the big thing happens, of course, when you start connecting an energy router to another energy router. This is the internet effect. And this is what we call the C side. So the C side is connected, it's a DC port to another building. And if we say that we have one flow of electricity coming from the traditional grid from the right, it connects to the first building. And then we have solar, we have battery, we have, if we have a two-way car, this means that we have 1 + 3 chances of having electricity available for us. But when we connect to another building and they have the same setup, suddenly we have 1 + 3 + 3. So now we have 7 opportunities of having electricity available. So the grid really quickly becomes very, very reliable. And these are the different sides we talked about. But let me just jump to a picture that we describe how we can do this in a neighborhood. So instead of having these 8 consumers being connected, each one with a grid, we're now building a little parallel electrical grid, and they are connected through these DC ports, and the energy routers, they can now send the electricity to where it's needed. And this is done with a software control, and the control is then managed through an open standard, something we call the EP, the Energy Protocol, instead of IP and the Internet Protocol. So this is something, it's an open standard, and we're just a couple of days away from publishing that and sharing that with the world. Everybody can use it, it's for free. But it means that we have a common language so that all of the different vendors in the future can build the support for this, so that the building will be able to ask another building, I need some electricity. Do you have electricity? Yes, I have electricity. Or it can say, I do not have electricity, but I can send the question to the next router. And if they have electricity, I'll provide a port so that I can transport the electricity from that building to you, and vice versa. Just one little detail for everybody who loves grid architecture. On the two sides here, you now have one connection to a transformer with the old grid, but you could also have another connection from another transformer to the grid. And this gives not only that we are never technically disturbing the traditional grid, we're giving them tools and opportunities and capabilities that they never had since the 1880s. They can now, with the software command, decide which of the two transformers should send electricity to this neighborhood, which of the transformers should receive electricity, and they can share it 50-50, they can share it 99% 1% or 99% 1, and it doesn't affect the electrical distribution inside the neighborhood because of this internet architecture, the new grid architecture. The flow of electricity from the outside will be automatically rerouted to where it's needed on the inside. And this is significantly cheaper, better, and it's also super resilient. So we believe, hopefully, that this will be the last piece of the puzzle to really unlock a profitable, fast distribution system that can enable the green transition, and the market will pay for it. So I don't know if I should stop there, Mark, depending on how much you want to go into details.
Well, let's go back to this all looking at each other on gallery, and then see. I think see if there are questions and discussion, because this is the idea. I just want to say to everyone that when the first time I saw Jonas give his presentation in San Francisco, I guess it was a year ago, March. And it was like, in fact, Ulla Derks, who as Jonas mentioned, Lund is part of this not only viable cities in Sweden, but this global joint initiative for climate neutral smart cities that GUD is a major partner of. And so all this has been going on for a while. So in September, we met in New York during Climate Week, and we sat down together at some cafe for 3 hours. And Jonas had this computer, and I was like asking, what about this? And what about this? So the thing is that because this has never existed before, it's kind of hard to imagine, like, oh, this is something that has just been created. You can't even, it's not, it's just being tested now. So you can't like see it operating in action in the real world yet. So you have to imagine. And it's hard for people to imagine, especially in this case, because it's such an awesome solution that it seems like, well, this is too good to be true, because we know, I've been in this innovation world for, since the 1970s. And people always come, I have the next big thing and it's great. And, often it's a lot of BS. So, but this is for real. So really let that in. And one way is now to engage in it. So ask him lots of questions or, whatever on your mind. Yes. So Aga and then Jane. Okay.
Okay, so my first question is, because, well, it does not seem that impossible from my standpoint, because it's like graph theory and internet. Yes, so basically I do understand that this is just mapping one idea onto another system. So through that mapping, my question is about was what kind of a router, or because I understand that those the green devices that are put into the structure of a graph, that these are those routers, or however you call it. So what is the architecture of that, and what is the safety of the transmission of basically the architecture of transmissions of such energy, just in a simple, obviously, as you would be explaining it to a laboratory, please.
That's
I don't
my
know if
level. That's my level. Yeah, it's like
I think
I don't know anything about technology.
my question relates to that. So maybe I
sure.
could just ask my
Yeah,
question
please.
as well also. I just so I guess getting back to the routers and things in cellular, or with the internet, there are different company and different providers and different ways and mechanisms that each home gets their services. And so I wonder if that has impact on the router, or how you connect. So that was one of my questions, which sort of relates to what I was asking.
Thank you. Okay, go ahead.
Well, these are really great questions, and I'm not sure if I speak Labrador, but I'll do my best. So the thing is, just on the box is really simplistic, and we're only using components that are already existing, and they're existing at very large scale, even hyperscale, and they are built for a much tougher environment, because basically we're using the parallel electronics from the electrical vehicle industry. And we had a little bit of a fluke or luck or whatever we want to call it, because as you know, positive news doesn't spread in this beautiful modern world. But the Volvo group, the Volvo Trucks company, part of the Volvo group, is actually by far the world's largest heavy electrical vehicle provider. So they have a world-leading knowledge about these kind of components, because it's the same controller chips that you use when you charge a truck or a bus. Because what you do is that you connect to a charger, and you don't just let the electricity flow. So you connect, you get a data link, you exchange some information, and then you start to ramp up the electricity until what is the capabilities of the cable, depending on temperature, depending on different things. And then you ramp that up. And then when you're seeing that the battery is starting to get full, you start to ramp it down, and then you say goodbye, and then you disconnect. So these are the components that we're using, and it's fascinating how cheap they are. Because of course we know about how electrical vehicles created hyperscale on battery, so we get an incredible price performance on battery going exponentially. But this is something that people basically missed, how the power electronics components inside the vehicles is the last piece of the puzzle to be able to do energy sharing between the different buildings. So that's just and what it means is that these four sides, let's say that we have 4 ports, A port, B port, C port, D port. Basically what you have now is that you have 4 different things, and they are connecting to something where the electricity can go in or it can go out. It can be AC electricity coming in, it can be AC electricity that goes out, it can be DC electricity that comes in, it can be DC electricity that goes out. But all of these ports are now connected on the inside. This is what we in the computer world call the backplane. So that if I take energy in on one port, I can translate it into AC if I want to, or DC if I want to, but I can send it out on any port, and I can send it out all of the energy, or I can send out part of the energy on that port and part of the energy on that port. But nothing happens because you get an electric flow, which is the old world. It happens because of a software command says that you are now to take this amount of electricity with this quality and send it on the bus, and then this device is getting another software command to pick up the electricity if it needs to be transformed or changed quality and distributed. So that is the simplistic version of what the router is.
And let me just show you, this is how simplistic. When we were in Lund doing the EnergyNet forum at Lund University, Jonas said this thing. I think I only said it once, but I loved it, and I've now said it, dozens and dozens of times. He said that in the old system, the electrons rule the asylum, but in the EnergyNet, the ones and zeros control the electrons.
I get that. Can I have additional question to that?
Yes.
Sure.
Just as a continue, as next step. So if it would be hacked, because we are here dealing with totally different amount of energy, like down in the internet transmission. Yeah. So what is the bad scenario? What is the possible disaster that can happen?
Well, so there isn't really a lot of things you can do. So first of all, we do know cybersecurity to a high degree. So the system will be sophisticated, it will be hardened, and just this is not, everybody can say that they think that they know security. But so as an example, we were the company that built Israel's national broadband network from 2013 to about 10 years, and then of course we had to leave the country because of ethical reasons. But not a lot of people, might come as a surprise, do not like the Israelis, and it means that we got a lot of training to fend off people trying to destroy infrastructure, and also there is inside the NATO cybersecurity command, there is a competition that they have run now 3 times. It's called Locked Shields, which is the highest. It's like the world championship of these people that try to save infrastructure for the NATO countries. And the team captain of the Swedish team, they've won 2 out of 3. And he's the guy that is ultimately responsible for the security design that we have. So first of all, it is hard to hack. The second thing is that this is the same thing with internet, and this is really, really clever. If you describe the internet to somebody and you don't say the internet, and you say that it's a network that is owned by enormous amounts of entities. Everybody built their own little network. They have a common language, and they connect it, and then they allow that to make sure that they can share it with everybody, so you can have a low-cost communication everywhere. People wouldn't believe it, and then everybody thinks that, well, there has to be a secret network, like a real network, the professional network for the grown-ups. And of course, you wouldn't put your military stuff or your government stuff on this internet. Well, everything's on the internet. So, but the thing is, because it's so distributed, there isn't really a super clever place that you can just, if you hack that, you can, darken the country. On the contrary, it is very easy to shut down the electrical grid as it is today. So whatever, let's say, vulnerability that you could potentially create, this is, a million times more secure than what we already have today, because the long distribution lines where the things need to be in it's very easy to just do a short circuit in two places, and you could have a large part of the country go dark. And just as a quick example of that, it was a terrible day. So the 22nd of November 2022, one Russian explosion took out 97% of Ukraine's power distribution abilities. All of the power plants were working, but they couldn't get electricity to where it was needed in the hospitals and so forth. And a lot of people died. But this is much more secure. So cybersecurity, it's an issue, but we're not really worried about it, because you can't, there isn't a single point that you can knock out. You could, take over one router and you can turn off an interface, but then you would just, reboot it and it would be back online again.
I totally get that. Sorry, the last question. This question was rather about hardware. So how those routers burn in case of how they burn, go down.
Burn?
I mean, burn, yes. Meaning that if something goes bad on one point, I'm not talking about the safety of the whole net, because I understand that
sure.
in parallel to internet. But I'm just saying, if a router of internet goes, well, the hardware goes down for any possible reason, it won't burn that much, as if I imagine. Correct me if I'm wrong.
Sure.
They're heavy metal. It would have to be really high heat for them to melt.
But we're talking about the electricity. So that I'm just
No,
if I'm wrong.
exactly. So I mean, it's a fair question. So what happened? It's the same thing that if a charger would malfunction, basically, if the heat goes up too much, if it doesn't stop when it should, I mean, the worst thing that will happen is that port, that interface will burn out. But it means that it will basically melt, and then it doesn't affect the rest of the system. So the component could burn out. Like you could have a port in your computer switch. If you have 24 ports, one port could be destroyed. It's like, oh, I can't use port 23, but if I connect it to port 22, I'm good to go again. So the component itself, but it is also worth to remember that these are components that are coming from an industry with much harder requirements than we have, because these are built into these big trucks and buses, and they are built to be able to withstand, crashes and heat and vibrations and lots of stuff. Now they're in this nice little cozy, room protected by concrete and so forth. So.
Yeah, and
okay, that answers my concerns. So thank you a lot.
I wish you would have been there at Lund University because these guys from Volvo, in fact, the guy was the chief engineer that designed the whole joint combined platform for doing the electric trucks, which is like the biggest investment they ever made. And he was there, and the other guy, and they have this component that, have you seen the movie Despicable Me? Or anybody? Anyway, it looks like these kind of cute orange and black goggles, and like that's it. That came from the heavy electric trucks at Volvo, and that's what they're using for EnergyNet.
Just as a small detail, but it's just because it's built. So, for an example, this is the connections that Mark talked about. So you inject the cable. And because it's built for trucks, then there's a security device that you put down, so it's physically locked. And this is because if you collide with this and the battery weighs 500 kilos, it's really interconnected, and the vibrations, and so it will not release if it's not completely broken off. So even that is much better than the traditional electrical distribution. But then the other thing is that there's a very clever thing. So you have two large cables where you can do the big voltage. There's a small cable on top of it. So you have a physical security layer on top of everything that's digital. So if you disconnect the cable, these small cables will disconnect before. So before you can have access to ports that could have electricity running on them that could be dangerous. Because this was pulled out before, physically shuts down the distribution. So it's just examples of that. It's not perfect. People will find a way to do stupid things, but it is way, way, way better than what we have in the traditional so-called grid architecture.
So, and I'm Banning,
so how come it is cheap?
Go ahead, what?
Sorry, how come it is cheap? That's my last question.
How come it's cheap? Go ahead.
How come it is cheap?
Because of the hyper volume. Because of that, you build so many more trucks, buses, and electrical vehicles, then you build transforming stations. And it's a new paradigm. So it's also built with an incredible competition. It was really interesting. When we started, the maximum we did was 800 volts, up to 800 volts on one interface. But even now, because people want to charge their electrical vehicles as quickly as possible, because we're impatient as a species, now we have components that are 1500 DC volts, just because people want faster chargers. And there's thousands of very serious engineering companies competing about building a faster charger, faster batteries, and so forth. And we can just take that volume. This is like building the computer networks versus the telephone networks that, the upgrades where you had ISDN 0.064 megabit, and then you had in the office, you had 10 megabits. And then when they were very proud about their development, they doubled the performance. So they had 0.128 megabits. And then in the office, you had 100 megabits. And that was because you had so many more office ports than telecom ports. And then, of course, there was a little bit of a cartel and so forth. But so this was open standard versus closed system as well.
Okay, now we're getting really in the weeds, which I'm sure is perfect place for Banning to be with his technical brain. But I just want to check, Jane, did you get your question answered? Oh, wait, you're on mute.
Yeah, I think that it explained it. I just wondered about the having having some of I guess all of the pictures were showing different types of houses, but they all seem to have solar or something along those lines.
Well, that's the whole.
That was just what they look. Yeah,
but
whole otherwise.
In other words, you could do this like in these tests, the starter kits. You could test it of moving electricity between buildings. You don't have to have the solar panels, but the whole point of it is this enables rooftop solar to to just explode. Everybody
need to have it. Solar
panels everywhere on every roof, and now you're sharing all that electricity.
That was sort of just a picture
through a whole system where you can move it from building to building to building. That's what's so amazing about it. And it's way cheaper, you say. So, okay, Banning.
Yeah, I was wondering what are the technical challenges and the cost curves on connecting single individual homes? Like where I live here, we have 2 acres of land and the nearest person is maybe 300, 400, 500 feet away. Is it feasible? And what's the cost? How is it going to be done to have this, what seems like a no-brainer for, apartments and office buildings? Seems like a different set of challenges. And I'll just add one more point here. We looked into solar power here, and the way that it's structured with the way they build it and the way it's structured with the local grid is that if the grid goes down, you go down. you can't like run your house on the solar you have because it's connected to the grid. I thought, well, that's stupid. Why would I bother to do it? The whole point is to have your independent distributed energy. So we got a lot of challenges with these energy companies, at least in New Mexico. So anyway, I'm curious, how would you approach this for places, particularly in the United States, where just so many people live in suburbs and, you know, long distances between houses?
Yeah, so the two different questions, I mean, take them in the reverse order. You're absolutely right. It's insanely stupid to you know, not allow your electrical distributed solution to work when the traditional grid can't help you when it's most valuable. But that is an easy fix, and it's just you know, it's just unimaginable electricians. Yeah. So it's an easy fix, because basically what the argument is that they need to have one breaker, and that's the only breaker. And if that breaker is off, there should not be any electricity. And then they say, if you have this system, it could send electricity backwards and electrocute the person doing it. And of course, we are not pro electrocuting anybody, but it's as easy as saying, well, if we have two breakers. So it's a really easy problem. And then the other thing, of course, is that we can, you know, software control it. So it's also, you know, it doesn't just happen. Electricity doesn't happen. If it's not getting a software command, it's not sending electricity. And that's also why we're using these very different connectors to show for electricians, for an example, that this is something completely different. If you don't know what it is, scan this QR code and talk to somebody that knows what this is. On the cost of parallel infrastructure, this is a really interesting parallel with the fiber infrastructure, because what we did with that when we built the broadband network, so that we really built a new cable towards every single household, basically. And what is really interesting is that Sweden is a really weird country. We have very few people, but we have, for Europe, a large landmass. So we have in the northern Sweden, we have areas where you have less people per square kilometer than you have in the Sahara Desert. So we have a little, you know, practical experience of this rural versus urban environment. And the thing is, it evens out very nicely, it has been shown, because even if you have longer distances in rural, it's much cheaper to navigate those distances, because it's not as complicated to dig, because the marginal cost here is digging. So typically, if you have a farm, it's easier to put, you know, you're gonna maybe go a kilometer, but you know, they could be like 50 meters in Los Angeles could be more expensive than, you know, 3 kilometers in an urban, because of zoning and practical and, you know, other infrastructure and these kind of things.
Yeah, so these are just.
But the system is just as practical to run like to an individual house, and you're on the same network with everybody else, just like the internet. In other words, if you could really make it like the internet wherever you are, except that we probably can't do it through Starlink here.
Yeah, but Dan,
no.
so keep in mind, so these are just standard copper cables. Jonas calls them freedom cables. But this is the coolest part. I love this. This is solar entrepreneurship in terms of the model that you're talking about. You could put solar panels on the roof of your house, right? And now and everybody's connected to the EnergyNet. Now you have a transaction software on your smartphone. So you say, oh, I don't need my electricity. I could sell it. You see? So you could be selling your solar electricity and making money off that, helping pay for the system. And everybody will be able to do that.
Well, what do you need to install between the houses? What kind of both the physical, you know, cables, as it were, is it copper or fiber optics or whatever? And then what, you know, so we try to wire up a whole network in a rural area is a very different job than doing it in the middle of a city, I would think, or one building.
Yeah, so the thing is, between the buildings, it's just typically the same type of electrical cable that you already have. So in a perfect world, which is something we're going to work on, of course, you could get access and pay a neutral rent to the existing power cable and use that with the new grid architecture. And once we win over the electrical distribution companies, they could actually use the new grid architecture, and they could upgrade their way of doing electrical distribution over the existing cable with this new technology and getting it controllable and robust and so forth. So that is absolutely possible. But the big thing in Europe is that because we can do it in all of EU, we can now prove the model, and we can get another good set of policies that you have to have. So in fiber in Europe, for example, if you have the equivalent of AT&T or Comcast, if you built your business under a monopoly, you have to rent on a neutral price your infrastructure to any competitor in the market. Meaning that you can get technology competition based on the same existing infrastructure. And the price for that is set by the authorities, not by the owner of the infrastructure. So there's a lot of things on top of that. Yeah.
I mean, the US had a big problem with all the local power companies, different states. I mean, it'd be kind of a nightmare until it sort of reaches a certain critical mass and everybody realizes they need to do it, accommodate to it. But the key point you're making here is that you can just use the existing infrastructure to move the electrons, and then in each house you'd have a router, and connect it to the EnergyNet, and so it's pretty simple to build on what we already have. It doesn't require building out new real infrastructure in terms of the transmission of the electricity. It just requires all the other things like changing policies. And
Okay, Banny, we'll talk about strategy in a little bit, and about Europe and about US. So we'll get to that. But what you just said was beautiful. That was so well said. That's exactly right.
Good. That was it was a big question mark in my mind, because Europe is a very different place in terms of the buildings. I mean, Stockholm is not Los Angeles, and
We'll get to that.
for good reasons.
We'll get to that, but we want to make sure everybody absorbs the technical reality of, oh, this is good and this is how it works, and I understand. And so let's stay with that. Any other questions anybody has? Nancy, you have any questions?
Well, I think it was answered in this last conversation, and that was about heat. Is that how hot do the cables get? Can you control that?
We can control it in two different ways. But the core thing here is that this is the difference between, as Mark said, where the electrons, in the old world, the electrons run the asylum. And you can get, the electrons can run away from you. You can get, things that are not intended happening, meaning that you can get a spike. And the spike could trigger, frequency problems, but it can also trigger heat problems that can, in the worst case, burn off the cable. As this is digitally controlled, we can, do measurements and things when we install. And there are some of these things that you do. If you start losing what you send and what you receive, you can see that, okay, so probably the heat is now, something is off here. And you can go into a safety mode, saying that this cable needs to be checked, but we can reduce it to this, and then we see that we get, the loss that we expect. And these things happen automatically. And this is as it actually works today with the charging. So these things are already built into how we do charging today. So in a nutshell, it is incredibly much safer, and it's way better to control. And because things doesn't just happen, they are ordered, and then they are feedback, and then you can also set the software limit that we are uncertain about this cable. So we're only going to do, let's say, 400 DC volt of transmission here.
One more question is, I wondered are you moving electrons between, let's say, two houses in DC or AC? Or either one?
We can, yes, we can use, basically we can use either one, but when we can choose, we prefer DC because it's just simpler.
Yeah, and well, you get your solar is produced in DC, right? So that you don't have to have an inverter and all that kind of stuff. But you would move it between houses. They could choose if you had two houses that are both have their routers and everything, they might want to just move it by DC and never convert it to AC as a
Absolutely.
loss
So
every time you do that, right?
yes. So our default is always DC, and the back plane is DC. Yeah.
Okay,
Okay.
Lukash and then Aga. Lukash, please.
I wanted to ask about the previous question about the money. What is the minimum amount of money that you have to invest? Because if we would like to establish a pilot study, we will be asked how much we have to pay at the university to get the 1 or 2 routers for the lecture building, for example. So it is also interesting for me.
Of course, yes, and we see that, and we have heard that from different places, which is fantastically encouraging. So we're actually part of the global initiative that we talked about. We are talking to also the Swedish authorities and the different stakeholders about. So we want to create a clever, what is the cheapest, fastest way to get the minimum of 2 routers so we can start doing the software parts and controlling things, and then doing like a larger, so smaller and larger starting kit. So one could be more for a lab to get the students involved and things like that. And the other thing could be that you actually want to create a connection between 2 buildings on a campus or something similar. So we're really going to do that because the cost thing today is basically that they are not produced, they're not put together in an industrial process. All of the components are, commercial off the shelf, but they're not, produced. That's why if we can say that we're going to talk to the Swedish government and say, can you help us to subsidize this, and so that we can build like 10 starter kits or 50 starter kits and 50 large or 10 or whatever, 50 small and 10 large. Then if we make that a package, we can make them much cheaper, because then we can standardize the construction of them.
Fantastic. Aga.
Well, I just wanted to say that this is not the first time where architecture and urban design is learning from automobile industry. In gasket transfer of technology from General Motors. So I think, that's a perfect clue here that we're in the line of long tradition of learning from the cutting edge automobile industry. And I think there is a point there, because boys love cars, and from that
Right.
that simple fact, we have a lot of innovation over there, so we can learn from that. And that was just my final remark. So I think there's a great technological possibility there. I believe in that.
I just want to share, a defining moment for me was the 3 days of the EnergyNet forum that we had in London at Lund University, because for one thing, I brought Dan Kamen, who's like one of the Nobel laureates for the Intergovernmental Plan on Climate Change, is like the top clean energy professor at Berkeley for the last quarter century, who was like a total believer in this. So that's always, reassuring, but what was interesting is just in general, you had, this group of real experts, in electronics, in the internet, people like Jonas. In energy, you had 2 of the top energy professors in Sweden were both there. You had these production guys from Volvo, and so across this whole spectrum of every way you look at this, there were like major experts. And then the whole thing for 3 days was like, tell us what's going to go wrong, tell us why this is not going to work. Do you know what I mean? And it was like mind-blowing. I mean, everybody said it's going to work, and so that so then I was so energized when I came back to Berkeley after this, like, because I know nothing about any of this, but it just seems clear that this is just a brilliant solution that people that had the same experience with the internet were able to bring to energy, and now we have it. And I think it's a game changer for the world, because it will enable, it levels the playing field. You see, now anywhere in the entire world, you don't need to have any fossil fuels in the ground. You don't need to import any fossil fuels. You can have locally generated renewable energy and storage powering most, basically all commercial residential needs. So that only leaves the old grid with the big power plants and the, you know, that system for very heavy users like big industry, transportation, data centers, and so forth. And then they won't be, you know, hoarding it, taking it away from everybody else, because we'll have abundance of renewable energy through the EnergyNet.
I have one more question.
Jane, please, yeah.
Yeah, I just had one more question. And this is again about cost, but it's really the consumer costs, because is there are there particular times when you're going to be using more energy than other times, and how would you be actually figuring out how you would pay for it as the consumer and the homeowner the usage, where we're charged all the time in our high volume days of doing a lot of laundry and things like that. I don't know.
No, exactly, and this is exactly the same thing as the internet. Because of the price performance on the grid, and you increase the competition, we could, you know, go from very expensive international calls or even national calls, and then we could suddenly have a pretty low fixed cost for all the communication you wanted, and it was even global. And we believe that this can be, you know, replicated. So one of the big things here is that we are building two different examples. First, the one we're gonna, you know, launch on the 26th of April, the world's first EnergyNet. It's a technical pilot we call EnergyNet Zero. But the interesting thing is that we already have two CDs that are now using an analytic tool that we developed together with this professor that, you know, used to do all those electrical things. And we can now simulate what we call EnergyNet 1, which is where we prove the commercial points. So basically, in a Swedish context, you have a neighborhood. Installing these things, you reduce the amount of power you buy from the traditional grid with 60%, because we can just now put up solar panels where it wasn't allowed before because of the gridlock. But we also put 24 hours of battery for all the consumption in this neighborhood. So you go from being less than a second away from having a blackout to that you now have 23 hours and 59 minutes and 59 seconds to fix it. So and this balances it out very nicely. And just on the average on the calculation. So for 6 months we will not use the traditional grid at all. We will not buy any electricity for 6 months. And this is in Sweden, where we don't have a lot of solar. A lot of sun, but the thing is, if we add local wind to this, the days where we need the traditional grid goes down to only 14 days per year, and the maximum is 5 days in a row, and this is because the Swedish climate where it's cold. But the thing is, so it's really feasible to build something that is completely off, that doesn't need the traditional grid. But when you have this kind of mechanisms, you would be paying an average price. You would not be, you know, being exposed to these very high peaks of cost. And the other thing is that distribution cost in Sweden is already higher than both production and taxes. And if we upgrade the old grid in the US, in Europe, and in Sweden, the only thing we're sure is that the consumers will foot the bill. So what is interesting here is that you say, well, you don't need to do all of these expensive upgrades, because we will take part of the responsibility locally, and we will offload a lot of effect from the traditional grid. And all of that effect, so if you just take Sweden as an example, if we just put standard solar, nothing fancy, nothing vertical, not even all roofs, but, you know, on all the roofs, we take just the good side, traditional installation, we would produce more than 50 terawatts a year that doesn't say much, but it's about a third of the total Swedish energy consumption would be produced locally just from solar. And of course, that frees up all of the green transition needs for transportation sector and for industry sector, meaning that just in Sweden, this is a saving of more than 200 billion euros that does not need to be invested in the expensive, ineffective, centralized old way. And of course, that saves the consumer tons and tons of money. So the thing is, today it's a centralized market. So if you don't set your own prices here, you could use your app. You connect to us. We want to be the world's first EnergyNet operator. So you say, I have solar. If I have more than I need, I can sell it. But you decide the price, not the energy company, not the distribution company. You decide the price, and then it's a local marketplace. And you could say, this is my good friend, my neighbor. I'm going to do free peering. We don't need to charge each other. But these guys, they could buy from me if they want. But because you don't have to pay for distribution costs, you can get a better margin for you, but still sell clean, green, local, super resilient energy that is less expensive for the users, even if you get a better margin to maybe put more solar on the other side of the barn or whatever is your local condition.
This is a win-win for everyone. The only exception is the fossil fuel industry. It's not a win for them, but it's a win for everybody else. Okay.
Yeah, they had their turn, so.
Yes, they had their turn. Time for a change. Okay, Sergi, do you have any questions?
Yeah, thank you, Mark. No, I was listening carefully, everything, just I was able to capture everything, no? I mean, yeah, just my question was I was wondering more with what Jen said, no, about the consumptions, no, they can be a balance, no? It will not be I don't know, you have been able, because what I understand, it's a pilot case, no? To see if you can optimize, no? Because at the end of the day, when we move energy, often also we lost energy during the transportation of the energy, no? In addition to that. And sometimes even I think storage, no, you can lose. I'm not an energy expert, but I think you can lose, no? I don't know, you make the assessment.
The traditional grid, it's only 30% efficient. So 70% of the energy is lost. Anyway,
I know it's a lot. Yeah. Exactly. No, thanks, Mark. So my question is, no, you have been able to assess all of this, no? Let's see the performance of this network. What is the total efficiency of the network in terms of use the consumption, how it's distributed with the needs and the production, and compared to another one? It's what I think partially you responded before.
Absolutely. And the thing is, this is we have a lot of great energy experts that have been simulating and doing things with this, but it is everybody in the sector knows this. And the thing with it is that you basically only have 2 peaks during the day on a traditional household, right? And this means that when you can do an average, because we are now in the 24, because it's profitable to have 24 hours of battery. And of course, in a, you know, when we do the project in the year, that will give us 48 hours of battery if we want to. But the thing is, so you can go down with effect. So the thing is that it's on the simulations we have now. So you use 50% less effect from the traditional grid. And as we said, the different project here, it's 60% of your needs are now produced just by solar. And if you add wind, you basically produce all of the things that you need. And there's another thing that's very interesting, and this is a concept which goes in a little bit on the urban side. And this is the green boom town. Because we have a lot of smaller rural communities in Sweden where they already produce all of the energy they need by solar and by wind. And these people are eager to put more solar and wind, but they are blocked by the grid. They cannot do it. They're not allowed to. So they can't move the energy out of this thing. So if you think about the 14 days when we do need the grid today, what we see now is that they could build a large-scale green hydrogen. And if you can take away the last dependency on the traditional grid so that you could still be connected to the grid, but you could use it for offloading electricity, helping the grid. Then it becomes profitable to do green hydrogen already today. And when you get into more volume, you will be able to do that. So we believe that you should have an urban center. It would be great to have one or several green boomtown rural communities that you cooperate with, because they can, do large scale solar and wind, and they can produce, for example, green hydrogen that you can use as a backup for the last few days on the grid. But just why does it become so cheap? Why is it so simple? Well, one of the big things is that we really do it simple. And this is just a little quote that was from the debate with the telephone folks. There was really clever people at Bell Labs and AT&T and so forth. So they were really upset with us back in the day when we talked about what is the architecture, how we're going to do this. And my friend, if you're not smart by yourself, you're going to have smart friends. My friend, he did the last, there was a debate, and then they said as their last argument that your network, it's so simple, even stupid people can build it and operate it. And so we're going to call it the stupid network. And my friend got up and he said, the stupid network happens to be a very smart idea. Because if you really do serious infrastructure or industrial processes, you want things to be as simple as possible. And it can't be simpler than that you produce the electricity that you need on your roof and you consume it a couple of meters away from the production source. And this is like the internet. So if you have it available in your house, that's great. If you need to go to the next building or the next building, but you want to find the energy that you need as close to the source as possible. And today, when we do this, 1,500 kilometers of wires we do in Sweden, it's insanely expensive, but it's, and you get about 10% energy loss just on that. But it is also impossible to protect if you have a hostile party wanting to destroy, because you can't protect these incredibly long lines in the wilderness. It's impossible. So it's really about doing it, because we're not smart enough. We're doing it really, really, really simple. And this is the same principle that we used on the internet. We try to make it as simple as possible, to make it as robust as possible. And then we want people to be able to build their own level of robustness in their building or in their neighborhood.
I think that was one of my, I have about half a dozen favorite quotes from Einstein, and that was one of them. He said, the challenge is to make everything as simple as possible, but no simpler. Dominika, any questions?
No. I had the same question as Łukasz, that about the costs, because we are so excited and ready to build it here, and it's important to estimate at least the needed money. So.
And so let me just say that when in talking about the in the what we're working on, as we call it. So now we'll get to stress. Banny, do you have any other? I want you to be the one to tell all the amigos how great this is. So do you have any other questions?
No, I think they've been answered. I mean, I'd love to see it in actual operation, physically see how it all lays out. But it sounds like you can, if I understand it correctly, you could take a house or a building or apartment building and just pop this on the infrastructure that already exists. So you'd use all the same wiring, you'd use it wiring between buildings, within the building, and the router would actually be the one to control the movement. And then of course have to hook it up to your battery or your solar panel or your wind source. But you're still connected to the grid when you need to be.
Yes.
But you're not dependent on the grid. And of course, you hope that you almost never need to use it. But you don't have to do new infrastructure. So the real cost is just of course, the routers and solar, if you're installing solar. But if you were to just take this in a building that was not itself producing solar, you could still install it and link it to the other building or other source. And maybe beginning you only had 10% coming from solar or wind. But as you increase that percentage, and you're suddenly at some point you're connected to the grid, but you're off the grid. You're not dependent on it, and it doesn't control you. And it's sort of there if you need it. It's sort of like being near a river, and you have an irrigation system, and if you need a little more water, you can go to the river and get some, but you don't usually use it. So that's a very attractive piece of it. And I think in trying to sell this, I think it's really trying to show people how they can use the existing infrastructure and pop this on top of it for pretty minimal cost, and just move to another system. But in sense, it's incremental, because you could start installing this before you had a whole lot of solar to put into it. But you could be used, and as you produce more yourself, then obviously it just takes over. But the cost is very minimal, really. And as you explained, all this technology is developed for electric cars, EV. I mean, we have an EV and a charger in the house, and haven't seen a gas station in a long time, and it costs us about $65 a year to charge our car. That is $2.25 per full tank equivalent. So but we're still using the grid that exists here. We just pop it on top of that, and I think that's, people have to understand, it's not trying to tear everything. You have to start from scratch. You're going to rip up your house or your apartment, put all these new cables in and all this stuff. If they can understand that this is something that pretty low cost to make the transition, and then obviously huge benefit once you do make the transition. I think so. How to market this, how to explain it to the people you want to get on board is going to be really crucial, I think. And it's not easy, because like you said, with even the initial internet, people were kind of like trying to understand what the hell it is. I mean, it's it started as DARPANET, right? And here we are. We're all totally literally dependent on it. And so I think that's going to be part of the challenge. But I mean, you've got a simple product in that sense. I think that the idea of simplicity is correct. Yet it's ultimately very simple, just like the internet, and very distributed and fairly invulnerable. So
yeah,
anyway,
so a couple of things. So let me give you now the strategic overview, and Jonas could add this. So how is this going to unfold? So number one, it grew out of this Viable Cities initiative of the Swedish government with these climate city contracts and assistant demonstrators. So that's 48 cities in Sweden, and Lund being the first to create the EnergyNet, and to the first to implement it, although we don't know that for sure. And I was talking to Marcus the other day, it could be that Linköping might do the commercial pilot faster than LKF, so we'll see about that. But for sure, the first testing of the EnergyNet is happening in Lund, and it's being officially launched on Saturday, April 26th. So that's the birthplace of this in real time. But so number one, and Jonas, you could supplement what I'm saying, but Sweden has this model that I guess goes back to the housing policy in the 60s of having these what are called public housing organizations that are owned by the municipal corporations. So every city basically has one that they own. And these are run like private for-profit real estate development and management companies, and they build and operate mostly kind of middle income market rate housing, and they're big. It's more than 20% of all the housing in Sweden is owned by these public housing organizations. In Lund, which is a city of 150,000, the LKF, which is their version of it, they own 11,000 apartments. So, and they nationally, these public housing entities see the value of this, and they've embraced it and are committed to implementing. So that's going to play out, fast, big time. And because they see these, in addition to the climate benefits and energy benefits and all that, there's the market benefits. Number one, if you do, as Jonas said, if you the first commercial pilot in London is going to be 11 apartment buildings, so 250 apartments. So here, three things will happen. Number one, LKF, the company itself, is going to save a lot of money on their electricity costs. Number two, all of the tenants, all the residential and any commercial tenants they also have, they're saving money a lot on their electricity costs. And number three, which is to me the coolest part, now the tenants are buying the cheaper locally generated solar energy from LKF, not from the utility. So LKF is now making money selling the renewable energy. And so now the tenants, they get two bills. They get one for their rent, and Sweden has rent control, so they can't raise their rent easily. And the other bill is for the electricity, you see? So this is a market rate vehicle that's financeable, and it's going to grow at scale. What we're hoping the next step is going to be beyond public housing organizations. And, there's versions in a lot of European countries. They have a similar thing in Denmark and Germany, et cetera. I don't know. Does Spain have something like this, Sergi? Okay. I know, and Poland does not, right? Okay. But, okay. So the next step is then to go to just private developers, big for-profit developers, because it's great for them, you say. And so that's why, for example, we talked about the guy that did City Park. I think he would love this idea. So that's Europe. In Europe, and then in terms of the Lund is now creating something. So two things. One is in Sweden, all these cities are going to be doing it already. 3 or 4 are starting the process. In centered around Lund is what we're calling Energy Valley, which is a kind of equivalent Silicon Valley idea, except that this is all renewable energy. And so under this, and this is across the Øresund Straits between southern Sweden and Denmark. So in this analogy, Lund is a combination of Stanford and Berkeley. And Copenhagen is a combination of San Francisco and San Jose. And we're going to have a joint, it'll be the first graduate program in the world as at the university level, as well as research on the new grid architecture. There'll be joint between Lund University and Copenhagen Business School. There'll be kind of an anchor of this Energy Valley idea. In Lund, where they already have amazing tech park, the Ideon Science Park and the Medicon Village, now there'll be Energy Village. So there'll be a kind of a EnergyNet tech park there. And then the third element that, and it'll spread to the other cities, but the third element that Jonas talked about that I love is the green boomtown. So we have this city, Svebo, nearby, where, they're already doing the green hydrogen. And so you're going to have green growth businesses and jobs, even in these smaller towns and rural areas, connected with the growth of EnergyNet in the larger cities. So that's Europe, where it's all legal, and we want to see it spread to Poland and to Spain and everywhere. Now in the US, all right, so then there's a second piece. The second piece is in the joint initiative for climate neutral smart cities, which is global. So it's 2 cities in Sweden, Lund and Stockholm. It's Poznan, it's Bristol in the UK, it's Curitiba in Brazil, it's Bogota in Colombia, it's Oakland, California, and Zabagaba, Uganda. So in all those 8 cities will be tied together through the, other than Lund, which is already going to do it at scale, through the starter kit. So we're trying to find one university. Like, for example, now we have University of California, Berkeley's going to do it, you say. And so that's another way to spread this and hopefully get a lot of support for that global initiative led by Sweden, of which GUD is a partner. Now coming to the US, we want to bring this to the US. We're focusing on California. And we found a loophole because in the US law, the utility companies, they won't allow you to cross their lines. See, they have a monopoly. So you cannot move electricity from one building to another building because then you're crossing their line, you see. But there is an exception that's called behind the meter, which is that, you know, you have the sovereignty over your own property. Now, usually your own property would be just one building, but it could be bigger, you see. So now we're talking with the Port of Oakland, which is huge, and it's state-owned property. They could do the EnergyNet system in all their buildings, including they have their own local utility. They already do sell electricity to tenants. So then that would be something at a big scale in California. We're also talking about, and Jane, you should hear this, connecting it with affordable housing. So we're talking with the Turner Center for Housing Innovation and, you know, Bridge Housing in California. We're now talking with New York City Economic Development Corporation about this. They have a big development in the Brooklyn Navy Yard that's be private development there, but they're leasing land. It's publicly owned land. They may be able to do this, you see. So in the short run, or the immediate run, over the next few years, there may be ways to do this that get around the existing laws and regulations, and then to build a movement. We're already starting doing this in California, because since nonprofit developers and for-profit developers love this idea, we think that by 2027, there will be bills in the California legislature to change the laws, say we should be doing what Europe is doing with energy communities. So that's some pieces of the strategy. So I don't know if anybody has any questions about that, or Jonas, why don't you add? I'm sure you have a lot to add.
Yeah, but I think that's perfect, and basically, I think that there's the power of the EnergyNet idea is that it's really simple, and once you get infected by it, you start to see everywhere, in every discussion, every policy, about how the old grid is the problem. And you have, like in California, you have a law saying that you have to put up solar, and then you have specific electric gas saying that you can't put up the solar. and I just saw a big compilation that I will share with anybody that wants on you know, the incredible amounts of solar, wind, and batteries in all of the US that wants to be connected to the grid. So the grid really is the problem. It's the gridlock, and the EnergyNet really is the next technical disruption on just make it simpler, faster, better. So we're very excited to try to be a part of that.
Okay, let's just go around final thoughts. And you know, it's good that we recorded it, and we can now, Angela can watch it, and Felipe, and you know, I think this was really helpful, because you know, I've been, you know, I'm like a super advocate, and I can get people excited about the vision of how great it is and what it will accomplish for us in the world, but I have zero technical knowledge. So there always comes to the point where people start asking questions like, I can't answer that. So it's great to have these sessions with Jonas, who can answer all these questions and reassure people, no, this really does work. But anyway, let's go around. Banning, yeah.
I'm very impressed, Jonas, and I appreciate all this. And I think, as I said, a lot of thought has to be given to marketing. How do you explain it? Why should everybody care about this? Why should I even think about, you know, adopting this idea? Well, you have to start from there and then work backwards in how much technical information the person actually needs. I mean, you can layer it so that people, if they ask more questions, they can have it. That's why I said, I mean, it struck me that I hadn't understood the first time around talking to Mark that you just build on the infrastructure you already have. And then you just plop this in, then you're going to put a battery storage in there, and then you're going to put, you know, some solar. it's not starting from zero. It's not starting from scratch. And the cost saving of that, as well as time and everything else, is huge. So I think that's, I'm not a great marketer, but I think giving a lot of thought to how do you explain this to people and market it, because it's a great product, but it's not exactly intuitive. And I think the internet analogy is good, but we have the limitation of people's understanding how the internet works, right? That's hard too. I mean, they know the outcome of the internet, right? What they can do with it. I mean, it's like these cell phones. Probably there's 6 people in the whole world, if even 6, that could tell you everything about how this works, from tunneling electrons in a computer chip to how the GPS system works. But there are billions of people know how to use it,
Right.
and probably much better than I can. So how do you relate to that world where it's what you can do with it that matters, And I think that's a trick, that's what the market and your experience in Sweden with selling this will be really interesting. And, you can help us understand how do you market it, what works and what doesn't, to get people to understand, and what are the questions they have.
Wait, just hold on for a second. Sergi, do you want to say anything before you leave?
Yeah, before thanks for the explanation. No, really, it's interesting because from the economical perspective, you're moving from some kind of monopoly to another network is not a monopoly at all, no. So, yeah, what I said, no, when we're talking about transportation, we're talking about sustainability, but at the end of the day, all depends on the energetic model. It's one of the key elements, no. I'm aware this is more at the housing level, but it brings the possibility to make, maybe, for instance, we talk about the production of the hydrogen, no, with this, one of the key elements, how to produce the hydrogen with renewable energy, no. So I think it's very interesting idea. I was wondering, I will check, because I don't know, they wanted to do something similar in the port of Barcelona. Later it comes to me in mind, so I will do some check, because was some kind of initiative. I don't know the movie forward, but later it comes to my mind. So I will see if I can provide more information about that.
Okay.
But yeah, thanks for the explanation. I mean, again, I'm not an expert with electronics and all of this, but the overview was clear. And
I'd love to hear that. So yeah, check on Port of Barcelona. Let's see if we can do it.
I will check.
Thank you.
Thanks a lot, all of you. So hope we can see you soon.
Okay. Bye-bye.
Bye-bye.
Thank
Hi.
Okay.
Thanks.
Banning, we're going to circle back to you, but let's just go around. So Dominica, final thoughts.
I'm just excited and hope that we will manage to have it also in Poznan. So great. And very nice to hear all the time, Jonas, with your presentations. It's great. Thanks for that.
Thank you. Jane, we should bring this to Wheaton. Jane, final thoughts.
Yeah, I think this is terrific. I think I agree with Banning. I think we need to have something in plain English that people will understand. And I would love to be promoting it somewhere, but I at this point, I don't know if we need to test it more or what before we start promoting it, but I think we need to have some materials that we can share that are simple to understand, and that we can take with us to different venues that we, might be able to share with them. And I know Mark's talked about some of the groups that he wants to work with. I'm not sure, if we want to talk to any universities, Maryland, or some of these other schools. You mentioned Hopkins, something going on there. Or,
yes,
so,
things with Johns Hopkins. I didn't tell you about it. There's going to be There's going to be an EnergyNet forum in Washington in October, hosted by Johns Hopkins University. Yeah.
So that would be terrific in terms of linking at that, but hopefully we have some really simple material that we can happy to help develop whatever you want to develop, but more of a training and then type of material and informational. But so going through all the material, I was going, well, some of it's a little difficult to understand.
We want to have a 1-minute video animated that explains.
That would be cool. Yes, that would be very good. And it's a really great idea. Yeah, I'd love to implement it here. So
thank you.
Okay.
Okay, Nancy.
This is great. And I look forward to learning more. Thank you.
Okay, Banning, sorry I cut you off before Serge wanted to leave. Banning, any other thoughts?
Well, I agree with all this. I think that the average person, the first issue is cost. What's this going to cost me, both implementation and then a monthly bill? That's what everybody's going to worry about. So you have to, that's always the problem with putting solar up, right? Well, the long-term benefits are blah, blah, blah. And then you have to find a way to make it sound cheaper, et cetera. So cost is first, reliability is second, and resilience is third, I think. And I think that, it depends on where you are. If you're in Ukraine, that resilience piece is
Right.
number one. But I think that's, and then the climate benefits of it, and the overall benefits to society are obviously very. So I think we just sort of have to figure out what are the primary, what's the order of things? How do you explain it? Because I think it's like you've got a great product, but trying to sell it is not so easy. I mean, when first 3G phones came out, why the hell do I need that on my cell phone? Well, now I know, but it's not self-evident. So I think that's going to be the biggest challenge on the consumption side, getting it out there. Whereas I think what you're doing is phenomenal. I think it's the next step. So, congratulations. It's amazing.
Well said. And just one thing, because we I didn't even forgot to mention this, on Earth Day, April 22nd, we're going to be doing 3 EnergyNet hackathons in the world, one in Lund and one in Rivne, Ukraine, which is the FU to Putin, saying, okay, if Ukraine had EnergyNet, the lights would have stayed on, right? And then one in Oakland at Port Labs, and Jonas will be here for that, and he's also going to be speaking at Berkeley, and so this is the beginning of. I feel really optimistic. I think that it's going to get easier and easier and easier to explain it because it is so simple and the benefits are so huge. You saw you did that one memo in 2 pages, 5 benefits, 5 huge benefits. So it'll sink in, and once people see how much they're saving because of it, it'll grow fast.
One
Can I
other
just
thing is,
sorry, yeah, go.
no, I was just going to say that I started writing, 7-8 years ago about how we need to move to more and more production of energy, food, and product where it's consumed, and which is whether it's vertical farms and ultimately 3D printing or whatever. And so a world where it's a much more resilient world, much more independent world in the best sense of it. And, so I think it fits in that larger context of how do we make the world more resilient and people it's more democratic, right? You have more control over the means of production, which is very key. And the other thing that I said before, that the bigger picture on energy has been just the idea that, when you go to solar and wind, the fuel is free forever. And, that's the most obvious thing about going to renewable energy, but the least talked about, because that means you're not every day like an addict, sending your money to Saudi Arabia or, Russia or wherever, you're having to pull this shit out of the ground and move it, refine it, get it here. This is a huge thing for the environment, but also for the economy. It means you're not sending your money from your community or your country to somebody else every minute of every day. Otherwise, you go down. So even, you're already in it, selling solar, so that's fine. But when you think of the bigger picture of why the solar itself and the wind and the storage is so important, it's the end of paying for the fuel. You'll never ever pay for fuel again. You just pay for the electricity, not the fuel. And that's a very simple point, but it's not very often seemed to be made, but it has huge consequences economically as well as, of course, environmentally.